All right, so today we're going to do adding and subtracting unlike fractions. To add and subtract fractions, you always must have a common denominator. That means that the bottom numbers of the fractions are the same. And if they aren't already the same, then you need to use equivalent fractions. You have to create equivalent fractions so that you can add or subtract. So we'll do a few examples and I'll show some visual models also to hopefully clear some things up. So the first set we're going to do is addition samples, and we're going to start with the sample of 3/8 plus 2/4. So as we can see, our denominators, our bottom numbers, are not the same. We have an 8 as a denominator and a 4 as a denominator. So since those are not the same, we have to create equivalent fractions and find a common denominator. The best way to do that is to always use your least common multiple, and that's the smallest number that both of the denominators share. So the way I like to show that one is by creating a little table off to the side. So our denominators are 8 and 4. So if I just start listing my multiples of 8, 16, and I'm not going to go too much further. I always say rule of thumb, do 3 or 5 to start, but so we'll go to 24 just for fun. And then for 4, we'll do the same thing, counting by 4s, 4, 8, and I don't really need to continue because right here I see I have a common denominator of 8, a number that's occurring on both sides that's the same. Okay, so I'm going to end up using 8 as my denominator. So I'm going to rewrite my fractions over here with 8 as the denominator. Okay, now I always ask, how did the 8 become an 8? Well, if I go over here to my 8 column and I list it out, 8 times 1 is 8. And whatever I do to the bottom, you have to do to the top. So because we multiplied 8 by 1 to create 8, that was our rule. We had to follow that same rule. So 3 times 1. And 3 times 1 is 3. So now 3/8 is equivalent to 3/8. Those are the exact same thing. They are equal. Okay, now let's look at 2/4. How did this 4 become an 8? Well, if we look over here, 4 times 1 is 4. 4 times 2 is 8. So the rule for this, 4 became an 8 by multiplying by 2. And again, whatever we do to the bottom, we must do to the top. Okay, so now we have 2 times 2, which is 4. So 2/4 and 4/8 are equivalent fractions. They represent the same amount, the same value. So the last thing we have to do is to solve it, to add. 3 plus 4 is 7. And now we have common denominators, so our denominator stays the same. So our answer to 3/8 plus 2/4 is 7/8. Okay. Let's try another example. We'll jump over here and we'll do example B. Okay. Let's try 3/5 plus 1/3. And if you want to stop and pause and try and solve it and then click play and see if you get the same answer as me, that works as well. Okay, so first thing I'm noticing is I have 3/5 plus 1/3. My denominators are not the same. So I'm going to need to use some equivalent fractions to do that. And again, I like using my little table because it makes it nice and simple for me. So my denominators are 5 and 3. So I'm going to list 5 and 3, and I'm going to do the first few multiples of each and see what happens. So 5, 10, 15, 3, 6, 9. I'm going to keep going. 12, 15. And now I have kids that get stuck when they're trying to list their multiples, and I always say draw some dots or count your fingers, whatever's best for you. So like 3, 4, 5, 6. 6, 7, 8, 9. 9, 10, 11, 12. 12, 13, 14, 15. Okay? And then I'm seeing here I've got a 15 on my 5s column and a 15 on my 3s column. That is the smallest number that they both share. So that's the least common multiple. So I'm going to rewrite my two fractions here with 15 as their denominator, because that was the least common multiple. Then I'm going to go through and see How did the 5 become a 15? Well, if I'm looking over here, that's 5 times 1, that's 5 times 2, 5 times 3 is 15. So my rule is times 3. 5 times 3 is 15. Whatever I do to the bottom, I do to the top. 3 times 3 is 9. Now for my second fraction. How did this 3 turn into a 15? Well, 1, 2, 3, 4, 5. 3 times 5 is 15. And whatever I do to the bottom, I do to the top. 1 times 5 is 5. And then my last step is to add. 9 plus 5 is 14. My denominators are the same, so they stay the same. So my answer is 14/15. Okay, so we followed the same steps on each problem, listed our multiples, created our equivalent fractions, then solved it out. Okay, I did say I would show a visual, so let's look at 3/8 plus 2/4. Let's take a look at that. So if I draw a model for 3/8, and it doesn't have to be perfect. 1, 2, 3, 4, 5, 6, 7, 8. So I have 1, 2, 3, 4, 5, 6, 7, 8 pieces, right? And I'm going to color in 3 of them. 1, 2, 3. Okay? Now, I'm going to draw another picture to show 2/4. 1, 2, 3, 4. There's my 4 pieces. And I need to color in 2/4. Okay, if I wanted to put those together, they're not the same size pieces, so I can't do that. So I'm going to use a different color and I'm going to create the same size pieces. Okay? And to do that, I can do it a few ways. I can start splitting my 4ths in half to make 8ths, right? So now I have 1, 2, 3, 4, 5, 6, 7, 8 pieces here. 1, 2, 3, 4, 5, 6, 7, 8 pieces here. Okay? Now, how many total 8ths do I have colored in? Well, I have 1, 2, 3, 4, 5, 6, 7. So I took my picture and I created 7/8. Now for the 3/5 plus 1/3, we have, again, 2 models. Okay. 1, 2, 3, 4, 5, as equal as can be, but it doesn't have to be perfect. And then I'm going to color in 3 of them. Okay, that's that fraction. Now I'm going to do my other square or rectangle, and it's going to represent 1/3. So I have this split into thirds. I'll do vertical just to show you it doesn't really matter which way we go. And I'm going to color in one of those pieces. Okay, so here's 3/5. Here's 1/3. Okay, now if I look at this, I need to make them the same size pieces. So I need to add some thirds for this one. So there's my thirds, 1, 2, 3, which really ends up creating 15 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? So I need to create 15ths over here. And I can do that by doing my 5ths. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Again, I have 15 pieces now. Now I have 1, 2, how many pieces are colored? How many of the 15ths now are colored? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And that's where we get the 14/15. Okay? So we have the just the mathematical way of doing it, and we have the visual representation as well. Now we'll do some subtraction examples, just so we don't forget about those. Beware. All right, turn the music down a little bit. Let's try 1/2 minus, we're doing subtraction now, 1/3. So we're going to shift gears. We're going to subtract now. Same thing as addition. All the rules for subtracting fractions are the exact same as adding fractions. All the steps are the same. The only thing that's different is instead of adding at the end, we're going to subtract. So I'm still going to make my little table because I like my tables. 2 and 3 are my denominators, so those are the multiples I'm going to list. Okay, 2, 4, 6, 8, counting by 2s, and then counting by 3s, 3, 6, and I really don't need to go any further, right? I have a common multiple, and it's the smallest one that they share. So I'm going to use 6 as my multiple, my common denominator. Now, how did the 2 turn into a 6? Well, if I go over here, 1, 2, 3, 2 times 3 is 6. Whatever I do to the bottom, I do to the top, and 1 times 3 is 3. Same step for the second fraction. How did the 3 turn into a 6? 1, 2 times 2. 3 times 2 is 6, same to the top. 1 times 2 is 6. Oh, that's not true. 1 times 2 is 2, excuse me. And my last step here is to subtract. And that's one mistake a lot of people will make is when they get all the hard stuff done and then they go and they start adding because they forgot to look at the operation. So now 3 minus 2 is 1. And my denominator, just like addition, it stays the same. Okay? And again, if it's going too fast, you can always pause it. If you want to try one on your own, you can always pause it and solve it and see if you get the same answer. And if you don't, you can go back and see where you made the mistake as you listen to me solve it. Okay, B. Let's try another one. Let's do 3/4 minus 3/8. 3/4 minus 3/8. And I like using this as an example because a lot of people end up giving me an answer of 0/4 because they think that that's the way we solve it. So let's show how we really do it. We have 4 and we have 8 as our denominator. We're going to list our multiples of 4 and 8. And we get 4, 8, 12. And we have 8, and I don't have to list all the multiples if I don't have to. I see I have a common denominator or a common multiple right there. So 8 is going to end up being our denominator. And also this is a good example too because a lot of people like to just multiply the two denominators and use 32, which works. There's nothing wrong with that, but you're going to have to do a lot of simplifying at the end if you don't choose the least common multiple. So if your goal is to get your answer in simplest terms, then I would always recommend using the least common multiple. All right, so how did that 4 become an 8? We multiplied by 2, and whatever we do to the bottom, we do to the top, and 3 times 2 is 6. The 8 became an 8 because we multiplied by 1, and 3 times 1 is 3. And again, we got to make sure we don't make a mistake. We are still subtracting. 6 minus 3 is 3. And denominator stays the same. Okay. So that's how we add and subtract fractions. If you want to see the visual for the subtracting, we can do that also. What's nice about this one is we don't have to draw 2 boxes. We just use the same box. So we draw a box. Doesn't matter how big. And we're going to use this first fraction, 3/4. Okay? So I'm going to take this box and I'm going to split it into fourths. 1, 2, 3, 4 semi-equal pieces. Okay, and how many of those should be colored? Our numerator says 3. 1, 2, 3. So this is representing 3/4. Well, from this 3/4, I need to take 3/8. Well, that means I need to create eighths. And the quickest way to create eighths is from fourths is to split them in half. Now we have 1, 2, 3, 4, 5, 6, 7, 8 pieces, right? Now I'm going to cross out, because I'm taking away, I'm subtracting, I'm going to cross out 3 of those eighths. 1, 2, 3. And how many do we have left? 1, 2, 3. So there's our 3/8. Okay? So not too bad. So hopefully that was helpful. If not, go back, watch it again, keep trying the same problems. Eventually it'll start making sense. Then give yourself a different problem and see if you can still get it.